So after you turn on the system, the first thing is to start this LDI laser controller, and then start cellSense. Okay, after the software start, and this error message will be always on, and just click it away. So when you start the software, the very first thing is to locate your sample and choose the objective you are going to do the imaging. But I always start with low magnification. So the general software layout, so this columns, the microscope control. The second column is camera control, and the bottom is our spinning disk control unit, and the third one is our experimental control. And in the center, the main part, of course, the image display. On the upper right corner, there are two preset layout configuration. You should always start with cell imaging facility routine. If this is not just highlighted, you should click on it and start. It will give you this layout. The first thing is I will choose the objective lens I'm going to use, and whichever is selected, it will have this blue background. So right now it's a 4x. I'm going to choose 10x, which will change the objective to 10x. So normally I would recommend everyone to use the software to control the microscope as well. So the first thing I will change to the objective to 10x. Then I will go to this observation module. This one is one very important one. That the first thing, anything designated with E means eyepiece or ocular, which is for visualization of your sample. The second one clusters basically spinning disk confocal control. These are all different light paths. With G means green, GR means green, GR and RD means green or red, and RD means red. And the third part is basically wide field control. We'll come back to this very often. But first, let's just start with either bright field or DAPI or green fluorescent or red fluorescent cubes or DIC. So if you have a DAPI, you always start with DAPI. This will set the light path to the ocular so you can find your sample. And the very first time you start to use the ocular, you have to press the Excite remote control button on off to give you the fluorescent light. And also notice whenever you start the software, the Z position here, for the low magnification, this position should be 7,300, roughly in that range. All right, after you find your sample, and this of course depends on your sample holders and also slide or chamber. This number may change, but usually this for low power line 10, 20, or 4x. It's roughly in this range. This is a good indicator to find where samples are, because it's really difficult to find if you don't know where you're looking for. So once you find your sample, so you're ready to capture a picture, and then we will switch to either confocal mode or wide field mode. For low power line, namely no oil line, anything below 40, and I would use a wide field imaging mode. So for now, I will just go DAPI, wide field, and choose that light path. So this will switch the system to the left camera path, and then we should be ready to take a picture. But before that, every time you go through ocular, we have to go to the laser controller unit, because what happened is the laser safety interlock get activated when you visualize your sample, and you have to manually turn this back on. That's where show this big button fold. And for the very first time, after you click this, you need to click the toggle this on off. But because this was turned on before, this become active already.
To visualize our sample, we first go live and then focus on adjustments in the camera control and display adjustment sections. Under Multi-Camera 1, one can adjust the exposure time either by typing it in or sliding the exposure time slider. Micro, milli, and full seconds are the unit ranges. To jump in orders of magnitude, it is easiest to use the slider or type the actual unit in as well. Below the camera control are the display adjustment settings which, as the name says, will only modify your display and not your raw data. Although it looks like the camera can image in different bit depths, when you drop down the options, your resulting image will always be in 16-bit and those settings only refer to the display. The minimum-maximum mode as well as the auto contrast function are very useful to find your sample initially. Once you found a good range to visualize your sample, you can switch to fixed scale to be able to see differences in your staining. You should roughly aim for maximal intensity values in the 4000 range. Using the logarithmic scale for your histogram makes it easier to appreciate the distribution of the intensities than the linear scale. You can further inspect the image by zooming in and out to and potentially changing to a more favorable lookup table. Overall, your image quality will be determined by exposure time and laser power. Those will be lower in wide field mode and higher in spinning disk mode, since the spinning disk will block out 90% of your light and thus reduce your signal to noise ratio dramatically. A well-prepared sample will allow you to recover some of the signal by adjusting laser power and exposure time. The snapshot function produces a single-channel 2D image of your current view. The generated file will be called image and can be found in the display section as a separate tab.
So for the camera, there's one very important parameter, basically this pixel clock. This basically tells the camera run at a high speed or lower speed. The high speed means the camera will be noisier, but I run faster, or lower speed will be quieter and less noise. For a speed sensitive issue, you can run this faster, and then if we go to live, probably you won't see much of a difference in this picture, but if I zoom in and move around and go back to, it will be a little bit quieter. It's hard to see anything. And so that's another setting you need to change for the camera. And so beside the display setting, don't be confused with this with your data. This only affects the picture host displayed on the monitor. For the device unit, normally we just leave it alone. Please don't change it unless we teach you how to do it and what you need to change. So we'll talk about this in the future. So now this is the basic navigate around, find our cells, capture a picture. But what if we want to do multi-wavelength? Let's say we want depth and green together. So that's a handout in this column called Process Manager. And this you can handle most of routine image acquisition, namely time-lapse, 3D, or multi-position imaging, autofocus, and so on. So let's just try to figure out first, it's just how we acquire multi-wavelength. By default, if you start this routine layout, you probably already have this multi-channels listed. And click this expand. This will show you what that setting is. So this DA means DAPI, spinning disk. So you heard some noise. That means spinning disk is sliding into the system. But of course, normally for anything below 40x, we would not recommend to do spinning disk. But for this, just for demo purpose, let's just start with that. Now, if I select this wavelength, I go live. This works. So right now, this acquired check mark is not marked, that means this channel would not be acquired. And if you check it, this means this will be this picture will be taken. The first thing you notice, basically this picture become very low signal to noise ratio. So it dropped from 7,000 to 800. That's basically the spinning disk cut out almost 90% of the light. So you can either increase the laser or increase the exposure time to compensate. So for the spinning disk, especially for the low power line, the pinhole are not adequate for this kind of magnification numerical aperture. So you have to increase this laser quite dramatically to compensate for that. So I mentioned it's 90% out, so you have to do at least, I would say, just a double, triple of what we had. So I will just go to 80%, or you can just type in there. So that's where we recover some of our export time. I think if I go stop live and activate it again, it didn't change that much. I thought it would. Yeah, that's basically, I think, the pinhole mismatch, and you don't see it. But the picture did improve. If I zoom out with the mouse wheel, this histogram, and you can readjust this. So now we can change the exposure time through this interface too. You can just directly type in, oh, that's 2 seconds, sorry. I will just do 200 millisecond. MS. That's good. It will not do it, so we have to do this through here, through this slider. So let's say I will do 200, or I will just enter 200. And now the trouble is this discrepancy between this exposure time, which is alive, and the acquisition time. In this instance, you have to read the setting from what's active. It will input that number into this. So we're done with step here. We can expand to green channel, which I don't have anything there, unfortunately. And you can check acquire. You can do the same thing. You can increase exposure time to 200 milliseconds. And also you can increase the laser to much higher. And now I have a green show up. So now let's say that's all the 2 channel. I want to acquire the additional channel here. I'm going just to uncheck them. Normally you should not have this many in there. And now I just have a DAPI and the green activate. So if I take a start, it will take DAPI and a green. So it will have a 2-wavelength picture. So that's basically how you take a multi-wavelength picture. If you do the red, basically you just go to the red, live, and to check acquire, and adjust the laser intensity or exposure time as needed. And now we can take, yeah, this keep happening, so we have to do the. So then you have to read the setting from what we have done there again, otherwise you have to change it again. So now if I click start, it will do 3 channel. And what you notice here is called a test multi-channel. That's basically your base file name. You can ask to type anything you like, and that will be the prerequisite pre-string. And then later it automatically attaches the date and what kind of a image it is, multi-channel, and 2025 October 10 and number 65. And then it will be special file format. We can talk about that later.